Mike Jeffries, and this is the walkthrough of the 2x72 belt grinder I've just finished building. First off, I'd like to give a huge thanks to Goat & Hammer and Big Blue Saw. In the case of Goat & Hammer, I worked very closely with them to develop this grinder, and Big Blue Saw did all of the laser cutting involved in this build. For a bit of background, a couple years ago, I took a blacksmithing class with Goat & Hammer. Fantastic class. I'd highly recommend anyone in the Atlanta area give them a look if you're interested in blacksmithing. But once we finished the class, we were kind of hanging out, talking to each other, and the grinders that they'd designed for themselves became one of the topics of conversation. And Mark and I started talking back and forth, and one of the things he wanted to do was create a grinder design that could be given out to anyone who wants to build it. Belt grinders like this tend to be very expensive. Even the cheapest 2x72 grinders you can find on eBay or AliExpress or any of the other sites are going to be $600, $700, $800. And this isn't cheap on its own, but this is the kind of functionality you'll get in a grinder that's going to be more in the $2,000 to $3,000 range. So if this is a grinder you think you want to build, check the description of this video. There's going to be a link to a post on my website, nearchaos.net, that has the drawings you'll need to fabricate it, as well as some more detailed photos and information to go through the build. With this design, there's a couple things to be aware of. First off, we've got the big red stop button. So with the motor I selected, it was a convenient place to put it. If you're building your own, I'd recommend having an e-stop somewhere near the motor because it's easy to get to, and then somewhere that's accessible well clear of the belt path. Next up, we've got the tracking adjustment. This is a piece of 1-inch bar stock that was cut on a portaband and drilled through on a drill press. We've got tracking adjustment with this little knob here. It's really easy to use. There's a spring on the other side with some washers to tension the spring a bit that will push it into that screw and make it so you can get a very reliable tracking adjustment. Next up, we've got a sprung ratcheting system. So for changing out belts, it's real easy. And then setting your tension, again, super fast, and you can actually adjust how much of your tension step you've got between each of these notches by changing out the spring you use. After that, we've got the dual track tooling arm setup. So we've got room for a lower tooling arm and an upper tooling arm, and these plates can be flipped around and removed to go between 1.5 and 1 1/4 inch tooling arms. The addition of this was a suggestion from Matthew Parkinson when I was discussing the design with him. Huge thanks to him for the contribution because I think it adds a lot of functionality to this. And then the final big fun feature that was a fun addition to add to this is the ability to take the whole thing and rotate it 90 degrees. One nice thing with the center of mass on this, at least with the motor I selected, is it'll sit just fine in either orientation without the knob even being tightened. So it's nice, light, easy to move. I can do it one-handed if I really wanted to, but I like having a second hand on the thing just for the sake of not letting it get away from me. When designing this grinder, one goal I had was that it could be built by just about anyone. So this whole thing is designed to be either laser or water jet cut. So you've got a very simple 2D fabrication process that anyone can use nowadays because there's plenty of shops out there, including Big Blue Saw, that'll take whatever drawings you send them and cut your parts out, send it to you, and you're ready to start assembling. The other thing I did is, while I've got welding equipment and I know how to use a welder, at least well enough that it sticks together, not the prettiest stuff, but that's how it goes. This thing can either be bolted together or welded together. And that makes life a lot easier when you're trying to fit it within the workflow of your shop. One thing you may run into when using some of these 2D fabrication methods I've mentioned is that you'll see weird surface imperfections right where either the laser beam or the jet of water is transitioning from where it pierces the raw stock into cutting your real part. So there's a few places on here where there's small burrs that stick out or small divots in the material. If it's in a spot where it's going to interfere with either the tooling arms or some other feature of this, you'll want to go in with a file or a small sander or angle grinder. Pretty much anything will do it because this is all mild steel. Shave that down and it'll be ready to work. With this grinder, I designed it to use NEMA standard motor profiles. So I've got a 145 TC frame motor in here. It'll also take the 143 TC frame motor. It's all face mounted. And then with some adaptation, you can even get a 56C motor to fit in here. Main difference to be aware of there is the 56C is going to have a smaller and shorter shaft, so you may need to either do some sort of adapter or extension on your shaft to get the wheel in the correct place. But there's a lot of options that'll work. You can get a pretty wide power and voltage range out there across all the different manufacturers. I personally went with a 2 horsepower Balder motor, so it's the one I went with is the VL3515T. So far, using this thing, I've been very happy with the motor. It's got more power than I could ask for, and has only tripped the breakers about half a dozen times in the first few days. One thing you may notice as you're going through the drawings is that I did not go with specific recommendations for wheels or tooling arms. I put an example of the ones I used, and that's because there are a lot of different manufacturers out there that are making good quality products. The other thing is, depending on which motor you go with, if you go with the higher RPM motor, you typically use a smaller wheel on that motor. If you're going with one of the lower RPM motors, you want a larger wheel to get the same surface feet per minute on your belt. And then, for me, I wanted a very flexible head for my tooling arm, so I went with this combination setup from Baader. It's been great for what I'm doing, but it may not be right for your setup. Another thing to be mindful of when you're ordering flat sheet parts from anyone, the dimension you order it in is a nominal thickness. So this is all 1/4 inch plate. Does that mean it measures exactly a 1/4 inch? Nope, you're never going to get exactly a certain thickness. So in my case, the plate I got measured 0.243 inches thick. So a little bit undersized, which actually works great for this. All I had to do to adapt that stack of 6 plates to the 1.5-inch tooling arm, which actually came in a little bit oversized on its own, was add some shims between the last plate here and the outer plate that it's mounted to. Really quick, easy, couple of bucks worth of washers essentially, and it's ready to go. Another thing with this design is consider all of the hardware to be recommendations. You don't have to use this exact bolt, this exact nut. You don't have to use flatheads. That's all stuff I chose based on how I wanted to use this grinder. If you want to go button heads, go button heads. If you want to go socket heads, go socket heads. I'm using hex head bolts for a lot of this just because it worked well for assembly and for the setup and tools I had. But if it's something that'll work for you and it doesn't look like it's going to cause a problem, go for it. The one place that isn't the case is where I've got shoulder bolts because I'm using shoulder bolts as axles in a lot of different locations. And then if you use a similar wheel for the idler wheel, then you'll want to use the same sort of bolt because it's basically acting as the shaft for the wheel as opposed to just holding stuff together. There are a few very minor differences between the grinder I built and the one that's in the drawings. The most notable is, if you'll see how I've got these parts slotted and tabbed into here, I've got a small corner relief that's to get around the cutting radius of the laser cutter or water jet that you'd be using to fabricate this. One thing I noticed is on a few of the features I was getting a little bit less material left behind than I'd like. So I moved the whole location from where it was getting compressed by the nut to a location where it's to the side of the nut. So there's a bit more meat that's actually getting squeezed together in the drawings I've released. Beyond that, there's a few places here where I originally intended to put tapped holes where I decided I didn't like the tapped hole in that location. So I've swapped tapped holes for through holes and lock nutted it. And in that case, it's a situation where I've already modified these parts to reflect what will actually be in the drawings you're going to see. Before we wrap this up, I want to make one other quick safety note. So this big red stop button is nice and easy to get to when the grinder's in a vertical position. When it's in a horizontal position, it's a little harder to get to. So what I'll be doing as I build a stand for this is creating a secondary e-stop location. I would highly recommend, if you ever intend on using this in a non-vertical orientation, to do exactly the same thing. Not having to reach into the machine to turn it off is going to be a great way to make sure your fingers stay attached. Alright, that covers all of the critical bits of information you'll need before you start building this grinder. If there are any other questions you've got, feel free to reach out to me either through YouTube or any of my other social media channels, which you can find in my profile, or through the Nearcast.net website, which is where the drawings for this will be posted. And once again, I would like to thank Goat and Hammer for all their help with this design and turning the idea of, oh, we should build a grinder and make it available to whoever wants it, and turning it into something that's actually here in my shop. I'd also like to thank Big Blue Saw again for their laser cutting services that got this whole thing cut out in really nice turnaround time with some very good quality parts.